Flatards think Earth looks like this because they saw it on a flag. This and this are examples of an azimuthal equidistant projection, one of many ways of projecting a three-dimensional spheroidal surface onto a two-dimensional one. If you've ever tried flattening out an orange peel into a nice map of its former self, you'll have noticed the problem. Presenting a rounded 3D surface in 2D means that something has to give. In the case of an azimuthal equidistant projection, what stays intact? Lines of longitude radiate from the centre of this polar projection, so directions from the centre point will be represented correctly. In fact, the centre point is the only point on this projection where one can determine the direction and distance to any other point correctly. For other points, only distances along lines of longitude will be consistent with reality. Distances and directions between any other 2 points will be incorrect. Consequently, shapes and areas are also incorrect, and become increasingly distorted the further from the centre of the map they are. We'll come back to that. The azimuthal equidistant projection does have some practical applications, but for general navigation, the problems highlighted mean it's an absolute clusterfuck. For instance, they can't even find out how big their disk world is because the UN would stop them.
Of course!
It is claimed that they patrol the southern seas and stop anyone going too far and finding the edge of the world. What these oxygen-deprived mouth breathers have failed to consider are the logistical requirements of such an operation. So let's do the thinking for them. Let's get a ballpark figure on how many patrol boats they would need. The straight line. This gives a circumference of roughly 103,700 kilometers of ocean to patrol continuously. Place a boat, say, every 10 kilometers, so no flatard can sneak past under the horizon, and the UN needs around 10,000 patrol boats just to stop flatard explorers discovering the truth. That flatards claim that distances on land are the same on their fantasy world, they've failed to consider a simple and fundamental problem. Whilst you could just stick a landmass onto a polar grid without changing distances between its locations, you can't do so without changing their coordinates. The best you can hope for is to get one line of points matched up, but then the coordinates of everywhere else are wrong. It's inescapable. Consider, for instance, Australia. 30 degrees south of the equator on the eastern coast is the small town of Red Rock. Let's take this point here, 30 degrees south and 153 degrees 13 minutes east. At the same latitude on the west coast, just 6 kilometers south of the town of Lehman, let's take this point at 30 degrees south, 115 degrees east. The difference in longitude is 38 degrees and 13 minutes. If you were to set off from our point near Red Rock and drive west until you got to our point near Lehman, you would cover a distance over land between these 2 points of 3,687 kilometers. So what happens if we travel along the same 30 degrees south latitude line for 38 degrees and 13 minutes on the polar grid of the flat Earth? The 30 degrees south line is 13,322 kilometers from the geographic North Pole, and must be on the flat Earth too, for reasons we saw earlier. We know the longitudinal and hence angular separation between our 2 points of this latitude, 38 degrees and 13 minutes, or 38.217 degrees. The length of an arc on a circle subtended by an angle alpha is alpha pi r over 180. When we crunch the numbers, we find that 2 points on the flat Earth surface, 30 degrees south of the equator, and separated by 38 degrees and 13 minutes, are 8,886 kilometers apart. This is 2.41 times greater than the real distance between our points near Red Rock and Lehman. But flatards say that distances on land are the same on their giants, also screws up simple travel. Qantas fly direct from Sydney to Johannesburg in South Africa 6 days a week. It's a direct distance of 11,060 kilometers, with the flight taking around 13 hours and 20 minutes, at a speed of 830 kilometers an hour. As you might have expected, things on the flat Earth aren't quite so simple. Sydney Airport is 151